hang up on, everyone. I'm Rob from Italy. Let me introduce myself. My background is computer engineering, and currently I'm head of data engineering at Axion AI. And Axion AI is an Italian fintech company. And what we do is apply machine learning and deep learning techniques to financial time series. So our goal is to help portfolio managers with their strategies in asset allocation, leveraging on the power of AI. And specifically, me and my team are responsible for building and maintaining data pipelines within our technological stack. So from data retrieval from vendors to data set generations to serve our models. And today I'm here to talk about a problem that we've been struggling with for a while, and now we solved it, which is how to perform database migration in a clean, consistent, and reliable way. So before I get started, though, let me ask you some questions. How many of you already use some sort of relational database alongside your Python code base? OK, there is some. And how many of you already knows Alembic? OK, I hope this won't be too boring for you guys, but let's see. So to briefly go through today's agenda, we will see what Alembic is and why we need it. Then we will explore some migrations together. And finally, we will see a scenario that we have multiple microservices working with a single shared database. So to get started, what is a database migration? Well, it's a way to manage and keep track of schema changes in your database. And this is because when you use a database alongside your Python code base, your requirements might change, and you need maybe to update your schema. So for example, you need to create, rename, or drop tables, doing the same with columns, or defining relationships like primary keys, foreign keys, constraints, and so on. So essentially, a database migration is a way to bring the schema from an old state to a new one, but preserving existing functionalities. So to give you a better understanding of the problem, let's take as an example a typical development workflow, where we have our developer, Mario, a very Italian one, of course. And is actually working on a new cool feature for our software. And he needs to upgrade the schema of the database. So what he does is to work on a local branch, a dev branch, and also create a set of queries to migrate the database. So once he is ready, he opens a PR to Luigi, which is the code base maintainer and the database administrator. And before Luigi merges the code on staging, he has to make sure that the database on staging has been aligned with the set of queries that has been provided by Mario. Otherwise, the feature won't work properly. So once the feature has been merged and live for a while on staging, we are ready to propagate the feature on production. And again, before we do that, Luigi has to make sure the database on production has been aligned. And you can already see the problem here, right? I mean, every time a developer has to push a new feature, well, the database administrator has to align manually the database. Otherwise, we risk some problem. And this is a very error-prone process already. But it gets worse. Because what if our clients ask us for isolate their data because of any sort of governance policy of the data? Maybe they want like these silos of independent production environments. And the architecture will look more or less like this one. And the more clients we get, the more Luigi faces will look like this, because we have more money, but yeah, the pain is going to be bigger. So this is where Alembic comes into play. So Alembic is a Python library that provides us a lightweight migration tool for SQL Alchemy, and allows us to perform database migrations using Python and in a version-controlled way. So you can think of it as Git, but for database migration, where what we usually call commits in Git here are called revisions, and we can switch between different revisions with just a simple command. For example, if we want to go from revision R1 to revision R6, which is the latest in this case, we just do the upgrade operation. While if we notice for any reason that we need to roll back to revision R5, let's say, this operation is called downgrade. And you can track schema changes over time. And guess what? You can do that across multiple environments. So now Luigi is very happy. So to install Alembic is very simple. It's open source. You just run pip install Alembic, and then you navigate to your project and run the command alembic init name of migration environment, that in this case is just Alembic for simplicity. And you will see several files and folders in your project. So we can briefly go through them. On the root level, we have the file alembic.ini, where you set up the driver of your database. It can be Postgres, MySQL, Snowflake, whatever you can think of, and the credential of your database. And then inside the folder of the migration environment, we have the file m.py, which is the entry point that Alembic is running every time a migration is performed. And this might not seem important now, but we will see an example why we need to modify this, and it allows us to have some flexibility for complex situations. And then the last important thing to notice here is the folder versions. And in this folder, we will store every new revision that we will create. So the last thing we need to get familiar with before starting with migrations are ORM. ORM is a way to abstract from raw SQL queries. So we don't deal anymore with long raw queries in our code. We just use Python objects, so it's more intuitive. And thanks to SQL Alchemy, we can manage connections, transactions, queries in a very easy way. And to give you an example, we can create a new table, just defining a class. And let's say we want to create a table to store historical prices for equity, so that maybe later we can create a data set to train our models. So what we do here is to create a class called prices, and then we define the variable dunder table name, which with the name of what we want to appear on the database. For example, we want the table to be called prices. And then we have 4 columns. Date, which is just referring to the date of which the price record is stored. Then equity ID, just an identifier for the equity. And we can think of Apple, Microsoft, or any kind of stock you can think about. And then 2 self-explanatory columns. I hope you can actually see them. It's price and volume, and they are just float. And the last thing to notice here is that we want a single data point for the combination of column, date, and equity ID. So we define the primary key with these 2. So let's perform some migration together. To create a new revision, we just run the command alembic revision -m first revision. First revision is just the revision message that you want to give to Alembic. And we can see that Alembic is generating a new file, as we said earlier, on the folder versions. So let's have a look at this file. So here we have a few things to notice. The first one is the variable revision. And this is the identifier of the revision that Alembic is using to keep track of the different revisions. And here, again, it looks a lot like a hash commit in Git. Then we have the down revision, which is none in this case, because this is our first revision. So there is no previous state of our database. And then we have the functions upgrade and downgrade, where we instruct Alembic about what we do when we need to run the migration. So if we take the example that we defined earlier, in the upgrade function, we create the table prices with the column we talked about. And in the downgrade function, since there was no previous state on our database, we just drop the table prices. And then we make our revision effective. So we run the command alembic upgrade head, and we can go to our database to see what happened. So basically, we can see 2 things. The first one is that the table prices has been created as we expected. And also, there is a new table called Alembic version. And in this table, Alembic is keeping track of the different revisions that are being performed. So if you notice, this is the same hash commit that we have in our module. So let's complicate things a little bit. We want to create a data quality control on our ORM. So first of all, we create a new column called market. And in this column, we just save in which market the equity is traded. And again, I want a single data point for the combination date, equity ID, and market. But because private equity cannot be traded on public market, this field can be also null, and I cannot use a primary key. So I define a unique constraint with these three columns, date, equity ID, and market. And as a best practice, I just give it a name so that I can recognize the unique constraint. And when I wrote this example, I was getting really lazy, so I thought, yeah, this is the perfect moment to introduce the auto-generate feature, because a very cool feature that Alembic provides us is the possibility to compare our database to the ORMs that we have in our code base. So in this case, once we run the command alembic revision -- auto-generate, and then again a revision message, we can see that on the table prices, a new column called market has been detected, and also a unique constraint has been added. And finally, again, we have a new file in our folder version. So let's review this file. This time we can see that, well, we have a new revision ID, of course, and the down revision is exactly the same that we were referring to before. And then in the function upgrade, we are defining the column market as expected, and defining the constraint for the combination of the three columns. And again, in the downgrade function, we just bring the DB on the previous state. And trust me, this code was all generated by Alembic. I didn't touch it, so it's basically all the work done for me for free. So we run the migration again with the command alembic upgrade head. We can see Alembic is changing the revision ID of our database to the new revision. And on our database, we can see that the unique key has been created, and also the revision on the table Alembic version has been upgraded. So let's perform one more migration together. This time, a very simple one. I want to rename the column market to MIC. MIC is just a standard way in finance to refer to the market. It stands for Market Identifier Code. So what I did here is just renaming the column and make sure the constraint is applying to the right one. So we auto-generate the revision with the command we saw earlier. We can see that Alembic is detecting a few changes, and then we can confidentially upgrade the DB with the command alembic upgrade head, right? No. Guys, we just broke to that production today because, yeah, we didn't review the code produced by Alembic. So that's a perfect lesson that we always have to check what Alembic is creating for us, because it's a very cool feature, but we can lose control of what we are doing. So in this case, if we review the code, well, we can see that Alembic is actually not renaming the column market, is dropping the column market and creating a new one called MIC. And this means that we are losing all the data that was in the column market. So there are some things that cannot be detected by Alembic automatically. And here's an overview of what Alembic can detect and what it cannot. And this is from Alembic documentation, so you can get it also from there. So for example, Alembic is very good in detecting table and column additions and removals, or column type changes, or even simple constraints like the one we did earlier with the unique constraint. While Alembic is not meant for detecting change of column and table names, as the example that we just did, complex constraints, and data migrations. And I want to stress this point a little bit because nobody's preventing you to use Alembic for data migration, but you can lose easily control of what you are doing in your database. So my suggestion is to have Alembic taking care of the changes in your schema, and then have a secondary script that actually add the data. So the last topic I want to cover today is a scenario that happened in my organization, where we have multiple projects working on a single shared database. And, well, if you think about that, it's a very common scenario, because maybe we have project A that needs some data from project D, and things like that. But how Alembic does respond to this? We can define a set of ORMs in each of those code bases and try to perform migration independently. But there are a few problems that might arise from this. So the first one is about the Alembic version table that we saw earlier. How do we keep the revision identifier aligned? Because if we don't have control of what is happening externally, well, Alembic will detect things that are not from our code base. So the solution comes from the file m.py, which is, again, the entry point that Alembic is using every time we perform the command Alembic upgrade head. And here we can configure the context of the migration and set an extra parameter to it. We can say that the version table, I want to be called PyCon versions. So basically, we are doing this operation where we take the Alembic versions table and renaming it in PyCon versions. So eventually, we will have a situation that looks more or less like this, where we have every single project referring to its own table version, so that we can keep the revision separate from each other. So there is also another problem that might arise from this, because we said that Alembic auto-generate feature is very cool. Yeah, but if we have a very simple scenario like this and we cannot use it, it's actually useless, right? So how do we prevent this? And how do we stop Alembic from saying, OK, I didn't see my table on your code base, but I saw that on the database, so that means that I should drop the table. But we don't want that, otherwise we can face data loss again. So we can, again, modify the file m.py and add another extra parameter to the configuration of our context. And in this case, we are passing a callable function to the parameter include object. And in this function, we are defining the logic of which object in our ORMs we want, in our database, we want to consider in the migration. So to go into details, let's say we have a code base called PyCon something. We rename all the table coming from this code base with a prefix like PyCon. And then we define the function include object that basically is saying, well, all the objects that are table and are starting with the prefix PyCon, I want to consider them in my migration. Otherwise, just ignore them. And finally, the solution of our problem, it will look more or less like that one, where we have, for example, the project trading room and the project PyCon sharing the same database. And yeah, they have these tables that are characterized by the prefix that Alembic is defining for us. So the main key takeaways from this talk, I think, database migration is something that you need to use to keep track of the schema changes that you're doing, because the requirements in your software can change over time. And one of the tools that you can use in Python is definitely Alembic, that provides you a version-controlled way to run database migration, and it's similar to Git, so you can get a grasp of it just knowing Git. Auto-generate feature is very helpful, but remember always to review your code, because otherwise you can lose the control of what you're doing. Alembic is not meant for data migration. Otherwise, nobody is preventing you to use Alembic as data migrator, but is at your risk. I don't want any responsibility for this. And finally, you can define complex situation using the file m.py that gives you flexibility to these kind of scenarios. So guys, I think that's all. Salamat. And I added the GitHub repo in this QR code if you want to play around. That's a code base I use as a playground for this presentation. That's my email and the website of my company if you want to reach out. So yeah.
Okay, thank you for that. All done?
Yeah. No.
Okay, thank you for that wonderful talk. For everyone who would like to ask questions, kindly just go here and ask them. Yes. We're able to accommodate for plenty of questions because Mr. Landi's presentation was very quick.
Thank you.
Okay, yeah, just feel free to go here.
Hi, I'm Hernan. So, sorry.
Yeah.
I want to ask, before you told us earlier that Alembic detects changes in the constraints, right? On only simple constraints, and it doesn't detect any changes on complex constraints. So what constraints are simple and what constraints are complex?
Yeah, basically, Alembic can just detect unique constraints and foreign keys or primary keys. Otherwise, I just suggest to make sure you do the migration with your constraints inside your module, so you get the full grasp of and full control of your migration. So yeah, basically that's it.
Thank you.
Hello, thank you for your talk. My name is Kirill, and I have a question about broken migrations. Sometimes you can see when migrations are broken in a strange way. For example, you start with a fresh database, and then months later, you return to a project and try to write new migration, but on empty database it is totally broken because some of the middle migrations assumes that there is some data in the database. So the question is, what is the better approach or technique to retest this migration from the scratch for different scenarios?
So if I understand correctly the question, basically you're saying that you have like a tree of migrations, and
Yes.
at some point there is one broken, but you have
Yes.
committed some other migration after that
Yes.
one, right? So this is a nightmare, right? Because you have to you have first to understand which is the point in which the migrations are getting broken. And I think Alembic is telling you with some logs when it gets broken. And then you have to go in your version folder and see the migration that is broken, at which revision identifier is referring to, the down revision. Mm-hmm. So if you think that you can fix that revision, well, you can do that. Otherwise, my suggestion is just to remove the revision from the folder and go to the next revision and change the revision
Yes.
ID. Otherwise, I cannot think about any other solution.
Okay, thank you.
You're welcome.
Hello, thanks for the talk. So my question is, you mentioned that Alembic can handle schema changes and auto-generate migration scripts. However, I'm interested in also if Alembic can also version grant queries or to track the different permissions that were added to the table.
Yeah, that's a great question. I have no experience actually with this, honestly, but we might see in the documentation if there is any referring to this problem, because honestly I didn't have any experience with this kind of giving grants to particular users or something. I don't know if you mean like giving grants to any specific user maybe or things like that. But maybe you can do, if you can do that in your in a row query, for example, you can also write a row query in Alembic. I mean, it's not like forced that you have to use SQL Alchemy.
Oh, okay, that's nice.
So
Yeah.
you can do that.
Okay.
But again, I wouldn't advise to do that, honestly, because Alembic works like a charm
Yeah.
with SQL Alchemy.
Okay. Thank you very much for that.
You're welcome.
Thank you.
Hi, Rob. I'm Dan. I'm curious about if we can use Alembic for CI checks.
Well, where we have put Alembic in our pipeline is that every time we have a job that has to run, let's say in the morning, we basically spawn a new cloud machine where we are execute the code. And this machine is connecting to a particular database, right? So before running the script, we just perform the migration to make sure that the database we are using is aligned with the last version of our code base. Because you can do the migrations also, if you can run Alembic upgrade head on a DB that has already been like at the latest revision, it doesn't change anything. Alembic will just ignore and it will not throw you an error or something. I guess you can do that also in the CI pipeline, and it's another way to approach the problem.
So it's like you do it on the side.
Yeah,
in
exactly,
parallel, right?
exactly.
I think I also have one question, is that does Alembic support serverless architectures like SQLite database?
I think so, actually. I think so. Maybe there might be some limitation because, SQLite is very, there is a few things that are not supported by normal SQL. But since you can use ORM with SQL Alchemy, again, you can use SQLite, and I don't see any problem with that.
Yeah, thanks, Rob.
As long as you configure the Alembic and INI correctly, you can do that.
Great. Thanks.
You're welcome.
Hello. Hello.
Hello.
Good afternoon. I have a follow-up question regarding to the person who I asked 2 questions ago about raw SQL. When should you prefer raw SQL migrations over Alembic's auto-generated migrations?
Again, you have to decide your approach, and it's basically up to you. For changes like, okay, I have to create new columns and very simple stuff that though is very like a chore because you have to write a lot of code that maybe it's very simple that Alembic can detect that automatically. Well, you can just do the migration, let Alembic auto-generate the migration for you, and you're good. You can also mix the approach, right? I mean, you can do your schema changes in your ORM, then you let Alembic auto-generate the code for you, and if there is something that it might be missing, you can just modify the changes, and Alembic is also telling you that, okay, you have to review this code and make sure to make the changes you need in the revision, so you can do that. So my only advice about this is, in a code base, just choose one approach, because if you have some queries made like row queries and some others with ORMs, your reviewers won't be that happy, honestly.
Thank you.
You're welcome.